So let's take a look at this question in atomic structure. This refers to 4 isotopes of cerium. Their mass numbers are given 136, 138, 140, 142. Then the relative isotopic masses are given, which is 135.9, 07, and so on and so forth. They want the fourth relative isotopic mass to also be calculated and the percentage abundance to also be calculated, given if they've given you everything else, and they've given the AR also. So you got to use this data to calculate first, the relative isotopic mass of the sample. So this is the end goal. Now what you must realize is you cannot find this without first knowing the abundance, and what works for abundance is knowing that percentage abundance should total equal to, so all of these 4 numbers that I'm just highlighting now, all of these 4 have to add up to, in yellow that I've highlighted, have to add up to 100%. So basically 0.185, 0.5, 0.251, 88.450, and the unknown y should equal to 100. So if I'm doing my working first, the way to get to the answer is the first part. So 0.185 plus 0.251 plus 88.450 plus the unknown y equals to 100, because I'm going to call this x and this unknown y. So let me get the y first. So when I do that, y comes out to 11.114%. That's 11% is the abundance of this particular isotope. And knowing that, I can find the AR using the weighted average formula. So I know the mass of each of the isotope multiplied by the abundance of the isotope over a total 100% will give you the average mass. So what I mean here is that the first isotope, which is 135.907, into its abundance, which is 0.185, plus the second isotope.
Quick pause. If you're finding value in this explanation, there's so much more to discover at Alt Academy, where we break down every A-level concept with the same clarity. Now back to the video lesson.
Which happens to be 137.906 times 0.251. The third isotope is 139.905, which is clearly the most popular one. That is the most common isotope. Plus, now you need to add the fourth one. You might like, hey, so what am I doing here? So let's just scroll a little bit more, so get some space, and maybe scroll zoom out a little bit, so I got some more space. So the fourth, the unknown that I need is, that's the x into its abundance, which is 11.114, what we just found, and all of this divided by 100 would equal to 140.116. So I'm just zooming out again to get some more space. So this is a long calculation, but this is what I get. So I take 100 that side and I solve for everything else. So when I solve this, honestly speaking, this value for x will come out to be 141 point something. Let me just do the math right now. So if I take a calculator, the blue value, which is 135.907 painfully times 0.185, is a lot of math. It's 251.25.1241427. So let me write it down first. 125.142795. Now since they want the answer to 3 decimal places, you could have done the math for 4 decimal places and then rounded off. But it is also merit to just doing the whole answer and then rounding it off at the end. It's just that there's too much to write. So 137.906 times 0.251, that's the one in green that I've written, the isotope in green. This multiplication comes out to 34.61161446. Now you know where I'm going with this. This times this, which would give you 1,2,3,7,4.59725 plus basically 11.114x equals to 100 times that will give you 11.6, and then you just solve for x. You add all of these up take them to this side and minus them from this, and then whatever you get divided by 11.114. When you take all of this and take it to this side, approximately you'll get you get an answer. Let me do the math also. So basically I get 11.114x equals to 1577.245549, and you divide this by 11.114 to get the value for x, right? So that 11.114, I get x as literally, let me just scroll down so I can get the value for x. I get x as 141.9152. Now they wanted three decimal places, so it becomes 141.915. That's the isotopic mass. It isn't difficult, it's just painfully long. All right, so that's the whole question. The data, solving it, adding all the abundances to 100, and then the other unknown, just solve it for the expression, and you'll get the value for x.
Hey there! If you found this A-level chemistry lesson helpful, why don't you head over to our website, altacademy.org, where you can sign up for the full A-level chemistry course. In addition to chemistry, you can sign up for physics, biology, math, or 4 other A-level subjects. Thousands of students have already taken the leap. What are you waiting for?